Unit 4.5, solving related rates. If y squared equals 3x to the power of 4 plus 6x, find dy dt when x equals 1 and dx dt equals 2. So first you have to find the derivative. So this is 2y dy dt equals 12x cubed dx dt plus 6 dx dt. You solve for dy dt, so 2y dy dt equals, and you plug in 2 for, you plug in x equals 1 and dx dt equals 2. So this becomes 24 plus 12. You solve, divide by 2, y. First we need to find what y equals. So the original equation, you plug in 1. And this becomes y squared equals 9. Square root of 9 is positive negative 3. So we come back over here, we divide by 2y, so we know dy dt equals 18 over positive negative 3. Guidelines to solving related rates problems. Number 1, draw a picture. Number 2, make a list of all known and unknown rates and quantities. Number 3, relate the variables in an equation. Number 4, differentiate with respect to time. Number 5, substitute the known quantities and rates and solve. Important: substituting a non-constant quantity before differentiating is not allowed. A rectangle example. The width of a rectangle is increasing at a rate of 2 centimeters per second, and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle increasing when its width is 4 centimeters and its length is 5 centimeters? So we know its width. First we write what we know. So dw dt equals 2 centimeters per second. dl dt equals 3 centimeters per second. The width equals 4 and the length equals 5. We're trying to find dA dt. So using product rule, we know that we can make dA dt equals length multiplied by dw dt plus width dl dt. We plug in our values that we have, that the equation gave us, and we find that dA dt is 22 centimeters squared per second. A triangle example. A police car approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the police car is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with a radar gun that the distance between them and the car is increasing at 20 miles per hour. If the police car is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? Label our thing. So this is y, x, and this is h. So write down what we know. When y equals 0.6 miles, x equals 0.8 miles, and h equals 1 mile. dh dt equals positive 20 miles per hour. dy dt equals negative 60 miles per hour. And we know it's the Pythagorean theorem since we're working with a right triangle. Derivative dt plus 2y dy dt equals 2h dh dt. And at this point we just plug in all the values that they gave us. So 2.8 we don't have dx dt, plus 2.6 negative 60 equals 2, 1, and 20. And we can find this to be 0.4 dx dt equals 112. Divide, and then we divide both sides by 0.4 equals 280.